Hey LPS students, so today's video is covering the CrossWord Generator.cpp program, and our goal in this assignment is to determine what letters a word may have in common with a bunch of other letters in a word list. So let's just start with a pretty simple example, and hopefully we can read this clearly from the computer camera. So we can imagine that we're given a word list as an array. So we can see right here. So let's imagine that we're given a word list and it has cat as the first element, dog as the second element, coat, good, and then a whole bunch of other ones. So what we're going to do is we're going to create a new data structure that holds all of the letters a single letter like cat might have in common with all the other ones. So we can see right here we have a crossword is going to be a certain data structure where basically each element in the crossword will correspond to an element in the original word list. So for cat's index, what it will keep track of is it will store basically a list of the same size as the word list, and each index it will keep track of the shared letters between all of the other words. So for example, cat has all three letters in common with cat, and then when we're comparing the next index in this basically list inside of a list, cat has nothing in common with dog, so we're going to represent it with an empty string. Now, in this next index, we're comparing the shared letters between cat and then the index corresponding to coat. So cat and coat, although they are different words, they still share the letters C-A-T. So we'll store those shared letters in the index representing where the common letters between cat and coat are stored. Likewise, so the next index in the crossword data structure will be all the shared letters for dog. So you can see dog has no shared letters with cat. It has all the same shared letters with itself. The next index, which represents the shared letters between dog and coat, is represented by an empty string. And then in this index, we can see that we're comparing dog with the index for good. And dog and good share a D and an O and a G. There. So basically, we're going to compare all the shared letters for each word in the word list, and we're going to create a list inside of a outer list that keeps track of all the shared letters. So we can think of this data structure as basically a big array, and in each index in the array contains another array of the same size. So let's say there are only 4 elements in the original array. Our 2D array will have, let's say, 4 elements. And then inside of each index, there will be another array with 4 elements. So in short, this crossword that we're going to be building is we're going to use a data structure called a vector, and it's going to be a vector that holds other vectors of strings. So hopefully that made sense. It will become more clear as we start to unpack the assignment. So the first thing we're going to want to do is read from the word list text file. And I'm going to break this video into certain parts. So part 1, we will just, let's say, get up to this point where we read everything in the word list and we put it into an array called word array, and then we are going to sort all the words in the word list in descending order. And we can use selection sort, for example, since we've done that on our merge sort assignment. Okay, so let's get started on part 1. And we can see here is the word list that you are provided with. So in total, it has 643 words in it. And we're going to be using one function throughout this entire this entire program, and it's going to be called shared letters. And it compares 2 strings, and it will determine the number of letters that are in common between 2 words. And it will return all those common letters as a new string. And we'll have that in the CrossWord Generator.cpp. So we only need to write one function in the CrossWord Generator.cpp, but we'll do that in part 2. Part 1 will be the tedious task of having to use ifstream objects to read a wordlist.txt file and then store all those words in a sort of array, and then eventually we'll want to make that 2-dimensional data structure, which is going to be a vector which holds other vectors of strings. But we'll get to that in a moment. So let's do the first thing first, where we're going to basically read all the words into an array. So you can see I declared a constant int for size, which is 643. That corresponds to how many words are in the wordlist.txt file. So the next thing we can do is create an ifstream object, and we'll call it, let's say, word list. And this will open the wordlist.txt file and read all those words into an array at first. So the next thing we need to do is create an array, and this array will hold strings. So we'll call this string, and we can call it words, and it will be of size, because it will contain 643 words. All right, and we also need to open the wordlist.txt file. So we're going to call wordlist the stream object, and we're going to say open wordlist.txt, and make sure, so I actually saved my text file as wordlist.txt, so I need to make sure it's a capital L. Great. And yeah, we can just open the text file for now. All right, great. So I provided this data structure for you since we haven't really learned about other structures besides arrays. And you can read more about vectors on your own, but for the purpose of this assignment, we're basically going to use this vector and have it hold essentially what you can think of as arrays of strings. So this is the 2D structure that I was illustrating here, CrossWord. Okay, and we want the CrossWord to have as many elements. We want it to have 643 indexes, which is the same as the word list, the total number of words. All right, great. So the next thing we'll want to do is we want to iterate through this vector, and it will have 643 indexes. And inside of each index, we want to build another vector that will have 643 items in it. So each index in the vector will contain another vector of 643 items. So let's use a for loop, and if we want to do this 643 times, we'll use our size variable, and so we'll make our for loop that will iterate through the vector. Great. And we want to, at each index in the crossword, resize that index to contain another vector of 643 elements. So we can do that by saying crossword at I, and we're going to resize the vector that's going to be stored at that index to size. Great. And so at this point we have the 2D, we've built the 2D structure that we need for the crossword. The next thing we'll need to do is we need to read from the wordlist.txt file. We need to read all these words into our array of strings, and then we'll sort this array of strings in descending order, and then at that point we can start to write the shared letters function and basically run through our vector and compare, or actually run through our array of strings and compare each index to every other index and seeing the common words. And then we'll put that and store it in our crossword. Okay, so we got a lot to do, but in this video we'll end at sorting, so reading our array of, reading the words in the wordlist.txt file into our string array, and then sorting all those words based on how many letters each word has. So we'll do it in descending order. So whichever word has the most letters will be at the first index, and then it will descend. So let's start reading from this wordlist.txt file. So what we're going to do is we're going to use this method called getLine, and it takes in 2 arguments. The first is the stream object, which will be the word list stream object, this one. And then the second argument will be a string, and we're going to declare a temporary string for that. So we're going to call this string, and it'll be called line. And what this will do is it will get every element on a single line in the word list and then put it where we want to. So it's convenient that this text file puts all the words on a new line, and I'm going to take advantage of that by using this getLine method. So we're going to get line from the word list stream object, and we're going to provide this temporary string called line. So we're going to put this inside of a while loop because we want to, while we can get elements on their new line in this file, we'll put them into our array. So we can say while get line at word list. So this will return true if there's an element to get on a new line. And what we can do is we can store whatever we find on each line into our array of strings called words. So we'll say words at, and we don't know what index we're using yet, and we'll put each line at a new index. So what do we put as the index? Well, we'll just create a counter variable. So we'll say int count, and we'll start at 0, and we'll put count in there, and then we'll update count after we store each element. So it will put the first line at 0, then update count, put the next line at index 1, and that should do. So this will successfully store every word, each one being on a different line, and put it in our array of strings called words. Awesome. The next thing we'll want to do is we already declared this counter variable right here. And we can see this is a comment for what we did right here. So he said, while we can read a line in the text file, we'll assign it to our array of strings called words, and we did that. Okay, next thing we can do is, since we've read everything from the wordlist.text, we can close our ifstream object, which is also called wordlist. So we're closing the stream object now. Great. Now we are in the business of sorting these strings. So we are basically up to number 4. And apparently the array is supposed to be called word array, but I don't think that's really hugely important right now. So now we need to sort the array of strings that we just read into in descending order. And we're going to use selection sort. So what we need to do is we're going to need to compare each word in the words array against every other word. And then, actually, sorry, that's the wrong comment. Let's put that further down. So we're going to start to sort using selection sort. And the first thing we'll do is we'll iterate through the array of strings called words. And we'll use a for loop to do that. And int I at 0, I less than size, I plus plus. And then we'll need to make a nested for loop that compares each word in the word array against another one. So that's similar to, what we did in poker when we were comparing each card in the int array against every other card. So we're going to use a comparison index. So use comparison indexes. And comparison index. And what we're going to do is we're going to initialize that to the next item. So basically, whatever this index is that we're looking at, we want to look at starting at the next index. So I plus 1. And we'll do this while comparison index is also less than size, and then comparison index plus plus. Alrighty, and so now what we need to do is we want to compare both of the words at index I and comparison index and see which word is longer. So we'll use an compare words at both indexes and determine which is longer. So we're going to use an if statement, and let's first check the element at I. So words at I, that will grab out whatever string is stored at that index. And we want to compare that against words at comparison index. Okay, so we know these are the two elements we want to compare. But now, how do we determine which word is longer? So what we're going to use is a method in C++ for strings. So if you look at all the include statements, I'm using a good number. F, file stream, IO stream, those are familiar for you now. I'm using the string library and then the vector library. So in the string library, what we can do is we can call the .length method, length. And this will determine the length of whatever string is stored here. Okay, and then we'll also do the same thing for the comparison index. And what do we want to determine? We want to see which one is bigger. So I'll see if, let's see, I'll see if the comparison index is larger than the regular index. Okay, and if this is true, what I'll want to do is I want to swap the elements per selection sort. So one of the first things I need to do is make a temporary string to store one of the elements. And then we're going to swap the indexes of the of I and comparison index. So let's do comparison indexes first. So words at comparison index. So this is the larger value, and we'll want to put this towards the beginning of the array at I. So, or rather, sorry, we're gonna put the smaller element. So this element we want to assign to comparison indexes. So we'll say words at I. Great. So finally, oh, sorry, I'm messing up the selection sort business. We need to keep track of what element was at the comparison index before we swap. So I meant to assign temp string to word at comparison index, because previously we overwrote whatever was stored here with this new one. So we stored whatever was at the comparison index. So the larger string, the larger word between the two, and we're going to store it in temp string. So we can even call this like bigger word. So we're storing the bigger word, and then we assign the smaller word to the comparison index, and then we want to, at the index I, put the bigger word. All right, great. And so this will implement the selection sort, and we're sorting in descending order. So that's why we're taking the larger word, the bigger word, and putting it at the beginning of the array of strings called words. Okay, so I think that's a good point to stop this part 1 video. We are currently, let's see, we're at 1 through 5, so we got some work to do, but this can be some of the the more trivial stuff, having to use if stream objects and read from files, etc. So stay posted for part 2, and that will potentially cover the rest. We'll see. Maybe there'll be 3 parts. But anyway, thanks for watching.